Stability of stars. The fragrance of an incense stick burnt in one corner of a room spreads instantaneously all over the room. Similarly, when the lid of a vessel containing boiling water is removed, the steam spreads in the surrounding region. Both these examples suggest that a hot gas spreads everywhere. Now, there is something to wonder. We know that the star is made up of hot gas. Then why doesn't the hot gas in the stars disperse into space? Our sun is also made up of a hot gas. But then, why have the properties of the sun remained unchanged over the past 4.5 billion years? The answer to these questions is the gravitational force. The gravitational force between the gas particles of the star keeps these particles together. But there is also a pressure of the hot gas which is constantly trying to disperse the gas. In spite of this tremendous pressure, do you know what causes the star to remain stable? Let us now find out the answer of this question. In the chapter of force and pressure, we have learnt about balanced and unbalanced forces. Let us recall about them. Forces that are equal in magnitude but opposite in direction are called balanced forces. Balanced forces do not cause a change in motion. On the other hand, when the forces acting on an object are not equal in magnitude and can cause a change in the motion as well as change in shape and size of the object, are unbalanced forces. This concept of balanced and unbalanced forces is crucial for the stability of stars. If the gravitational force, which is constantly trying to bring the gas particles close together, and the pressure of the hot gas, which is constantly trying to disperse the gas, are balanced, then the stars remain stable. The gravitational force is acting inwards towards the center of the star, while the gas pressure is acting outwards, that is, away from the center of the star. In the game of tug of war, two ends of a rope are pulled on either sides by each group. If the forces applied by both the sides are equal, they balance each other and the center of the rope remains static. When the force on any of the side becomes greater than that of the other side, the center of the rope moves towards that side. Something similar happens in the case of a star. When the gravitational force and gas pressure are balanced, the star is stable. But when one of them is more than the other, the star either contracts or expands. Do you know, if there would have not been any gas pressure in the sun, it would collapse to a point in 1 or 2 hours. Gas pressure depends on the density and temperature of the gas. Higher the temperature and the density, higher is the pressure. After learning about the stability of stars, let us now learn how does the star evolve through the different stages of its life cycle.